Last night I had a question that was, what is dark matter? What is that? Like, you hear about it in sci-fi shows and things like that all the time, but you don't really ever know what it means. Before we get into it, I just wanted to say thank you so much for telling me to keep doing this. I mean, I was really going to do it anyway, but I'm really glad that people are liking it and people are taking to it. And for those of you who said that you're only 19 years old, you can't teach anybody about anything because you don't ever learn about it, and you've never taken a physics class, you can shut the fuck. Anyway, so today we're talking about dark matter, what it is, and yeah, just what it is. So first, we know that the universe is always expanding. It's constantly expanding. You've probably heard that before, but don't really know what it means. For the longest time in the 20th century, we thought that the universe was always expanding, but it was expanding slower and slower all the time. So it turns out that that's not true at all, and it's actually quite the opposite. So the question is, what exactly is causing the universe to expand? And why is it expanding faster and faster? Every second, every millisecond, it's going faster and faster. Why is that? Well, we know that there is something that's creating energy. Because in order for anything to grow like the universe is growing, there needs to be energy that's forcing it to expand. So we need to find out what exactly is making that energy. What's creating this energy that is forcing the universe to expand? In order to talk about this, we're going to have to go back to Einstein's theory of relativity, or more specifically, his theory of gravity. Now, his theory of gravity basically states that anything with mass in space has gravity, but the strength of the gravity is caused by how much mass said object in space has. So something that's more massive than Earth has more mass is going to have stronger gravitational pull to it. And something that has less mass than Earth, obviously, will have less gravitational pull. Now, in order to talk about dark matter, we're going to have to talk about dark energy. Now, dark energy and dark matter both, we don't know exactly what they are, but we have very accurate theories as to what they should be. Now, dark energy, actually, there's not much known about dark energy. More is actually unknown about dark energy than is actually known. What we do know about dark energy and dark matter, really, is that we know that roughly 68% of the universe is dark energy. And we know that 27% of the universe is dark matter. Now that only leaves 5%. And that basically means that 5% of the entirety of the universe is what we like to call normal matter, which makes up things like planets and stars and things like that. Which is kind of funny because normal usually means that that's most often what occurs, but normal matter is only 5% of the entire universe. So it's pretty abnormal. Einstein was actually the first person to realize that space isn't completely consistent of nothing. There's not nothing out there. Einstein's theory of relativity and theory of gravity both state that space itself, as it expands, is creating dark energy and dark matter. As space expands, as the universe expands, it's creating more dark energy. And that dark energy is actually causing it to expand more. But we're not losing any of the dark energy that we already had, which means that the rate in which the universe is expanding faster and faster and faster, because it's only gaining that dark energy that's forcing it to expand, and it's not losing any. So that means that it will constantly be expanding faster and faster all the time. Now, dark matter. More is actually known about what dark matter isn't than what it actually is. Now let's get into 3 of the things that we know that it can't be. Now, dark matter and dark energy, both are dark. Now, what does that mean? Basically, dark, in this sense, means that it doesn't come in the form of a star or a planet like anything that we see. We know that it can't be a star or a planet because we know of the existence and the percentage of space that is dark energy, which is 68%, and we know that about 5% of the universe is actually normal matter, which means that 27% has to be something, so it's dark matter. Second of all, we know that it can't be clouds of just darker normal matter, and we know this because of using radiation technology. If it was clouds of normal matter, then it would absorb some of the radiation, but it doesn't. And finally, we can rule out that dark matter is a black hole, a galaxy-sized black hole, because it couldn't possibly be that. And we know that because in a black hole is the absence of light, and light can't pass through it. So we wouldn't be able to see anything if it was a galaxy-sized black hole. So it can't be that. The best theory for what dark matter really is it's made up of a hypothetical elementary particle that we have yet to find, that we have yet to discover, called an axion. Now, like I said, axions are hypothetical. They're hypothetical. We don't know that they exist, but this is the best explanation that we have for what's actually out there. What actually is dark matter? And an axion is actually the best way to explain it. So basically, today we learned that the universe is constantly expanding at a faster and faster rate, and that's happening because it's creating more dark energy, which is making it increase the speed in which it's expanding. And the universe is also creating dark matter, which we know can't be a planet or a star. It can't be any cloud of normal matter, and it can't be a galaxy-sized black hole. And the best theory for what dark matter really is an axion. That's fucking science. Thanks everybody so much for watching this. Please remember to slide up and let me know what the next question is going to be. I really have a lot of fun doing this, and I hope you have fun listening to what I actually have to say. And if you have any questions on what I'm talking about, all of this information is on NASA's website, really. I just condensed it and made it easier to follow. So thank you very much.